Hello, welcome to page 509. We're going to do problems 14 and 15. And for these problems, we are going to sketch a graph of an exponential function, which is this one. We'll start by making a table, and this one's easy, 5 to the x power. We know about the powers of 5. We've got that. Then we are going to find the inverse of that function by switching the x and y's. And then we're going to graph everything. Okay? Now I'm going to call an audible on this one because I don't really see the point of it. They want us to use -2, -1, 0, 1, and 1.5. I'm going to change that to a 2. So for my table, -2, -1, 0, 1, 2. Why? So I can do it in my head. I know what the powers of 5 are. 1.5 is the square root of 125, and you'll learn about that in chapter 8, which is going to be irrational. So I'd have to estimate it. And when we're done, I'll show you what 1.5 was with the calculator. Okay? So I'm going to change that to a 2 so that we can do it in our head. And also, for the problems on the homework, you can use these numbers right here, -2, -1, 0, 1, 2. Okay, that's fine. We'll talk about that in class. The purpose of doing it this way is to be able to graph it without the technology. That's it. Making your human brain smarter than it was. That's the whole purpose of it, all right? So I'm not going to get hung up in things like that. This is going to be my y value, which is going to be 5 to the power of x. So I want my powers of 5. 5 to the 0 power is 1. 5 to the first power is 5. 5 to the second power is 25. We know that. These two are the reciprocal of these two. So this is 1 over 5, also known as 0.2. And this is 1 over 25. As a decimal, that'd be 0.04. That might be helpful if I graph it, which I'm going to do. So -2 goes to 0.04, which is really close to the line, but remember, it's not exactly on the x-axis, excuse me. Here's the x-axis. -1 gives 0.2, which is also really close. It's about 1/5 of the way up. Okay, so it's a little bit higher, but still really, really close to the x-axis. 0 gives 1, which is right here. 1 gives 5, which is right here. And I'm off my grid. 2 gives 25, which is way up there somewhere. So now let's try to draw this exponential function. I'll just start right here. Remember, you're not connecting the dots, you're drawing a nice curve through the whole thing. This is not vertical. And on the other side, I'm going to exaggerate just a little bit. I'm going to try to put a gap in there. It's kind of hard to draw it with a steady hand. So I'm exaggerating just so you can see that there is going to be a little bit of a gap right there. Okay, so this is f of x equals 5 to the power of x. And that's all from the first section, 7.1. Got it. Now, I'm going to do the inverse. So I'm still going to have an input variable x. I'm still going to have an output variable y. And in this case, my y is going to be log base 5 of x, because that's the inverse of 5 to the x power. To make the table, I just switch the x and y's. So my x is -2, my y is 0.04. So now for my inverse function, my x is going to be 0.04, and my y is going to be -2. This will be 0.2, this will be -1. Where x is 0, y is 1. Now my x is, whoops, I messed it up. X is 1 and my y is 0. Dang it, I was doing such a good job. Instead of 1, 5, now I've got 5, 1. And instead of 2, 25, becomes 25, 2. I just switched the x and the y. Let's see if I can graph any of these. 0.04 -2 means I'm going to go a little bit to the right and down 2. So that's going to end up right here. And that is the reflection of that point. I'll make this just a little bit bigger so you can see it. I'm exaggerating the size of these points so that you can see what they are. All right, so this point right here, which is -2, 0.04, becomes 0.04, -2. 2/10, -1 is going to be about right here, and that's the reflection of that one. That's, don't look at that. 1, 0 is the reflection of 0, 1, so that ends up here. And 5, 1 is right here. So this curve, this logarithmic curve, looks like this. And I'm going to try to exaggerate this a little bit to show that it never touches, and I think I did, I messed up. That's okay. It never is supposed to touch the y-axis. So in review, there's a lot of details here. In review, you know how to come up with this table, draw the graph, flip the table where I've got x and y, and then draw that graph. Okay, let me do another one. All right. So you might panic and say, I've got 0.5. Guys, fractions are your friends. Fractions are going to help. Let's start off with my table for my exponential function. So this will be 0.5x. But you know what I'm going to use instead? I'm going to use 1/2 to the power of x. Why is that easier? Because I know the powers of 2. And again, this one they did okay. -2, -1, 0, 1, 2. Any number to the 0 power equals 1, except for 0. 1/2 to the first power is 1/2. And 1/2 to the second power is 1/2 times 1/2, which equals 1/4. And if you want to give the decimals, that's fine. That's 0.5, like we said, and this is 0.25. But why are the fractions useful? Because for these two, I need the reciprocals of these two. The reciprocal of 1/2 is 2. The reciprocal of 1/4 is 4. Now the reciprocal of 0.25 is also 4. It's just easier if you just turn the fraction upside down. Let's graph these. So -2 gives +4, that's right here. -1 gives 2, that's right here. 0 gives 1, right there. I'm exaggerating this, the points. 1 gives 1/2, which is right here, and 2 gives 1/4, which is about right there. So for my graph, my exponential function, it's going to look like this. And I'll try to not touch the x-axis. There you go. It gets closer and closer and closer, but it never actually touches it. By the way, since I started big on the left and I went down, this is an example of exponential decay from one of the previous sections. All right, now let's do the inverse. All I'm going to do is switch these two. So instead of -2, 4, I'm going to do 4, -2, 2, -1, 1, 0, 0.5 or 1/2, I don't care, 1, and 0.25, 2. And this function is y equals log base 0.5 of x. That's the function I'm actually doing, that's why we're learning about logarithmic functions. It's actually in the title right there, logarithmic functions. So let's graph this. 4, -2 means I go 1, 2, 3, 4, and down 2. And actually, just to make it easy, I'm going to switch colors. 4, -2 is right here. 2, -1 is right here. 1, 0 is right here. So I always have an rewind. I always have a y-intercept for my exponential functions, because where x equals 0, I get the y-intercept. But I never have a y-intercept for my log functions, unless there's a translation. We'll get that later. Okay, unless you slide the whole thing to the left. But I do have an x-intercept. So For exponential functions, I get a y-intercept, but it doesn't touch the x-axis. For the log functions, I get an x-intercept, but it doesn't touch the y-axis. That's cool. 0.51 is right here, and 0.252 is right here. So I'll see if I can draw this. This does not touch the y-axis. It gets closer and closer but never touches it. You've seen us do this on Desmos before and it looks like it does, but if you zoom in, it does not. And then that goes like that. So what I have is a reflection. The graph I drew in black got reflected into the graph that I drew in green. Okay, we'll see you in the next video.